In the previous video, we produced this here. I gave you a function f of x equals x plus 1 to the power 3 and asked you to find a quadratic approximation, and in the end we produced this here. Okay. Well, a neat way of getting from here to here is to use this formula here. This in a way is the same as what we did up here, but a lot more efficient. So looking at this here, in the previous video I gave you a function, this one here, and then we produced this quadratic approximation. Let me just rewrite this quadratic approximation. So our what we got in the end was our quadratic approximation equals. I'm just going to write this first. So the 1, I'm going to put the 1 first, plus, and then this term 3x, and then plus 3x squared. Okay, so looking at this here, well, when given a function, any function here, when given a function here, our quadratic approximation will be given by this here. Okay, so if you look at this, f of 0, so that's you evaluating the function at x equals 0. Now if you look at this here, this is what we did here. This is our evaluation at x equals 0 here. So we've actually evaluated at x equals 0. It gave us 1. So this 1 here is in fact, don't forget, when you start out with your quadratic and then you put 0 into here, these two terms here will automatically get killed off, leaving you the c. So c will always be a constant. C will always be this thing here. So if you c, our c will always be this thing here. So looking at this here, our c is always this thing here. Okay, and looking at this here, our b, this is our b here. When you differentiate it, and then when you evaluate it at x equals 0, then this term here gets killed off, leaving you just b, and look, you can see that b will always be this thing here, f prime of 0. Okay, so b will always be this thing here. So when you look at our quadratic here, this is our b. And don't forget, it's always in the form of ax. Let me just rewrite it differently. It's always in the form of bx and then plus ax squared here. So this here is our c here. B here is just f prime at 0. And don't forget the x. You stick the x in here, and then this thing here is really this bit here. Okay, so if you look at a, whenever we try and solve a, if you look at this here, whenever we try and solve a, it always leads us to this thing here, f double prime of 0. But then to get a, we have to get rid of this 2 here. So we have to divide both sides by 2 here, because when you start out with your quadratic, if you differentiate it twice, it will give you this, and then when you come to evaluate it at x equals 0, it will give you 2a, and then 2a will always be equal to this here. So to get a on its own, you divide it by 2. So the value of a here is always f double prime of 0 divided by 2 to get a on its own. So this thing here, this is our a here. Okay, so this is just a neat way of writing our approximation. In fact, when you become good at it, you would jump straight to this rather than having to work through all this here. Okay, so this is in effect the same as what we've been doing. This is our quadratic approximation. Remember, this is evaluated at x equals 0 here. So this approximation is only good near x equals 0. Okay.